engineers and scientists, bridging theory and application. This FGP is being held in association with Moulay Ismail University, Morocco, Private University of Fez, Morocco, and MathTech Thinking Foundation, India. The duration of the FGP is from July 18th, that is today, and it will conclude on July 31st. It is designed to enhance the skills and knowledge of this powerful computational tool that is MATLAB. The next 2 weeks promise to be full of learning, collaboration, and innovation. To begin our program, we would first like to welcome our dignitaries, Professor Dr. H.P. Singh, VSF, Honorable President of Day-1 University, Jaipur, Dr. Meher Chand, Founder and President of MathTech Thinking Foundation, Professor Zakia Hamok, she's not here with us currently, École Normale Supérieure Moulay Ismail University, Morocco, Professor A.K. Saini, Director Excitech, Dr. R.K. Chaurasia, and all the other faculty members and participants from different universities. We welcome you to this 2-week faculty development program. To begin and to provide a little more insight into the FDP, may I request Professor Chand, who's a professor at Baba Farid Group of Institutions, Bhatinda, and the founder and president of MathTech Thinking Foundation, to please address the audience and throw light into the objectives of the FDP and why is it important. So please.
Thank you, ma'am. Good afternoon, all, and welcome to this 2-week faculty development program on MATLAB for engineer and scientist, bridging theory and application. Respected Professor H.P. Singh, VSM Honorable President, the ICFI University, Jaipur, Professor Zakia Hamok, Associate Professor, Moulay Ismail University, Morocco, Dr. R.K. Chaurasia, Head of the Department, ICFI University, all the committee members and dear participant. Welcome all of you in this 2-week faculty development program. The highly anticipated 2-week faculty development program on MATLAB for engineer and scientist, bridging theory and application is set to take place from July 18 to July 31st, 2024. This program aims to provide a comprehensive understanding of MATLAB's capability and its applications in solving real-world problems associated with engineering and scientists, thereby bridging the gap between theoretical concept and practical implementation. During these 14 days, there are 14 sessions and several speakers has been invited, which are as Professor Zakia Hamok from École Normale from Morocco, Professor Pooja from Sharda University, Uzbekistan, Dr. Harmanpreet Singh Kapoor, Department of Mathematics and Statistics, Central University of Punjab, Bhatinda, Dr. Bharti V. Nathwani, Amity School of Applied Sciences, Amity University, Mumbai, Dr. Amit Kumar Yadav, School of Computer Science and AI, SR University from Telangana, Dr. Swapnil V. Kale, Department of Mathematics and Statistics, City Bora College of Arts, Commerce and Science, Shirur, Savitri Bai Phule, Pune University, Pune, Dr. Shal Gupta, Department of Computer Science, Gurukasi University, Bhatinda, Dr. B.S. Ratanapal, Department of Applied Mathematics, Faculty of Technology and Engineering, the Maharaja Sayaji Rao University of Baroda from Gujarat, Dr. Amit Kaur, Department of Physics, Baba Farid College, Bhatinda, Engineer Pikan Majumdar, Senior MATLAB Application Engineer, Ilmax System and Solution, Kolkata. This program is structured into 14 intensive sessions that cover a wide range of topic pertinent to MATLAB and its application in various scientific and engineering domains. With over 100 participants registered this faculty development program to be a vibrant and collaborative learning experience. This faculty development program is collaborative effort jointly by the FKI University, Jaipur, Mole Ismail University, Morocco, Private University of Fez, Morocco, Method Thinking Foundation, India. Participant can look forward to gaining invaluable insight from the speakers, vast experience, networking opportunities, and hands-on session that will enhance their skill in MATLAB. This FDP is an excellent opportunity for educators, researchers, and professionals to deepen their understanding of MATLAB and its practical applications in engineers and science. All the sessions we are trying to manage hands-on, and the content during the 14 days which will be presented will be provided to all the participants, along with the recording of each session will be available for the participants, so that the participants are from different countries, from different time zone, from Morocco, some are from Nigeria, Ethiopia, Malaysia, and all over India. So we understand there is always some issues for the participant who are from the different time zone, and they have sometimes challenges. So that's why we make everything smooth functioning, so that the content which will be provided and be presented during these 14 sessions will be available to all the participants and will be reachable to everyone. If the participant during the session are not able to join, then they can attend through the recorded lecture, which will be available in their account, and they can log in, and then after they can cover the content. Along with the, we have for corresponding to each session, there will be quizzes which need to submit to all the participants so that we can evaluate them. And it is also mandatory for to get the certificate of participation for this faculty development program. And I hope that the content, the resource persons which we arrange for this 14 days faculty development program, very friendly, and all the sessions will be open for the discussion, so that if any kind of question from the participant side, they can ask, they can collaborate them, and they can create their concept. Open discussion will be available there, and this is all about this faculty development program. And I hope that this will be very informative, knowledgeable to all the participants during these 14 days. Best wishes to all the participants, and thanks. Over to you, ma'am.
Thank you so much, sir. And as sir has already said, the sessions will cover a range of topics from basic to advanced MATLAB functionalities, focusing on how this tool can be applied in various teaching and research contexts. We will also have hands-on sessions allowing the participants to apply what they've learned in real time. Thank you, sir, for this briefing. May I now request Professor Dr. H.P. Singh, VSM, Honorable President of the ICFA University, Jaipur, to please deliver the welcome and opening address.
Thank you, Dr. Surbhijan. Good afternoon to all. Dr. Meherchand in particular, most welcome. I'm very happy the kind of introduction you've given. You made it very clear how this FDP is going to be conducted. And I am really impressed the way you have laid out the complete details. It's, I think, going to be a great benefit to all the members who are going to participate. And I'm also very happy that more than 100 registrations have taken place for this FDP. That only goes to show the kind of interest the participants have in this FDP. Let me start with, kind of thanking the organizing committee from ICFA Tech School of the ICFA University for taking this initiative of working out an international FDP. I would like to say it is just not limited to the FDP being done by UGC or within the country. It's got an international dimension because you have the private university of Morocco, that is Mole Ismail University, also jointly, doing this FDP. So the organizing committee of the ICFA Tech School, led by Dr. Professor A.K. Saini, who is the director of ICFA Tech School, and the organizing committee led by Dr. R.K. Chaurishya, Dr. Surbhi Jain, and other members, and all other faculty members from ICPI Tech School who are there to participate in this FDP. I'm very happy, and also those who are registered, those who are not physically there in this school, but they are from all over. I can see there are registration from MIT University and other. So all those who are present online today, ladies and gentlemen, good afternoon to you and welcome to this beginning of the FDP on MATLAB, which is basically for engineers and scientists. And as brought out by Dr. Meherchand, it is going to bridge the gap between theory and application, which is the need of the hour. We don't want just theoreticians, because theoreticians are not good enough. You need to apply and MATLAB is such a wonderful tool, which is used by all the faculties and used by students in various programs of their academics and studies. Therefore, it is extremely important that the faculties undergo the development program and refresh themselves, update themselves on the MATLAB tool, whatever the latest one happening in the MATLAB. And who could be a better person than Dr. Meherchand, who himself is the president of MTTF India, to be part of it and leading this program, joint program on the MATLAB and faculty development program. It's a matter of immense satisfaction for me that the ICPI Tech School has taken lead in looking forward to a joint FDP along with MTTF and with the Mole Ismail University. I think Dr. Jakia, Professor Jakia, who was supposed to have been with us, I think has not joined. But anyways, I think she would be joining soon and will be part of the deliberations that take place. So the next 14 days, I think 2 weeks from today onwards to 31st July, I think 1 or 2 hours, which is going to take place for the MATLAB, is going to be a very good FDP, because as brought out by Dr. Meherchand, it is going to be hands-on. It is not just, concept theoretical one, but the participants will get to do hands-on and the practical application of the MATLAB. And I think that's the best way to learn FDP, because FDP is to refresh, update the faculties on theoretical domain as also on the practical side. And the practical side is more important. And MATLAB is such a tool, such a vast tool that is used by our faculties. I'm sure all the participants, in particular the ICPI Tech School faculties, would definitely get benefited out of the deliberations that are going to happen in the next 2 weeks. I would also be, often, and of course, I can't afford to have 2 hours because of the busy schedule and other activities in the university. But I'm very keen to be part of this FDP. And whenever time permits, I would like to be part of it and also learn about. I know MATLAB, I have used MATLAB. So sometimes I will come in between and see how things are happening. I'm sure the 2 weeks are going to be very useful, very beneficial to all the participants and all the members who have volunteered to be part of it. And my best wishes to you. Thank you very much for allowing me to speak for 2 minutes, and wish this FDP all the very best. I'm sure it's going to be very good FDP. Best wishes. Thank you. Jai Hind. Over to you, Dr. Surbhi Jain, back to you.
Thank you. Thank you so much, sir, for your valuable presence and for setting the motivation tone of the day. And with your support and guidance, we're sure that we'll be having more such FDPs in the future as well. I think Professor Zakia is not here with us. Meher, sir, should we move on to the closing of the inauguration session?
Yes, ma'am.
Okay, sir.
And
So,
before you close, I would also suggest, we could look at some kind of agreement with MTTF and, agreement at the end of it or sometime, so that in future also we can have some kind of exchange and, have joint FDPs or some kind of, exchange program or something that will help us more than MTTF. I don't know. I think the university or tech school will get benefited more. So we can think about it and let's work out something like that. Okay, thank you. Back
definitely,
to you.
sir. We'll be in touch with MTTF for more collaborative projects and further collaboration. So thank you once again. And With this note, we come to the conclusion of the inauguration ceremony of the Faculty Development Program on MATLAB. May I request Dr. R.K. Chaurasia, HOD of Basic Sciences and ECE, to please present the vote of thanks.
You're muted. Unmute yourself.
Thank you, Surbi ma'am. Good afternoon to everyone. I am R.K. Chaurasia and I am here to present vote of thanks for inaugural session of today FDP. First, I want to thank our chief guest, Professor Dr. H.P. Singh, VSM, the Honorable President of ICFI University, Jaipur, for joining us today. Sir, your inspiring words have set a great start for our FDP. I also want to thank Dr. Beher Chand, Head and President of MTTF Foundation India, for sharing your knowledge and excitement about MATLAB. Sir, your talks have given us a clean understanding of its potential and uses. I would also like to extend my sincere thanks to other university, Maule Ismail University and Fez Private University Morocco for their invaluable contribution. A big thanks to Dr. A.K. Saini, Director of ICFI Tech Jaipur, Payal Madam, Surbi Madam, Sivan Sir, and Dr. Vijay Vyas, and other committee member also for their dedication and planning of this FDP. Lastly, thanks to all participants and technical team for making sure that everything will run smoothly. Thank you all for being here and keep learning. Once again, thank you to all of you. Thank you, ma'am. Over to you.
Thank you so much, sir. On this note, we conclude the inauguration session of the 2-week FDP. But before we move on to the technical session, may I request all the participants to please turn on their videos for a group photograph. We'll have a quick group photograph. I request all the participants to please turn on their videos. Requesting Ms. Payal Singhal to please take care of this. Thank you so much. So I would like to hand over the session to Dr. Meher Chand as we move on to the technical sessions. And I would like to thank once again to all the ones present here for the inauguration session. And we'll be moving on to the technical session now. Dr. Chand, please.
Thank you, ma'am. Once again, good afternoon to all of you, and welcome to the first technical session on advanced programming technique during this 2-week faculty development program on MATLAB for engineers and scientists, bridging theory and applications. In this session, our resource person will be Dr. Swapanil. Before inviting him, I would like to have a brief introduction about him. He is an accomplished academic and researcher specializing in numerical analysis, scientific computing, and high-performing computing. He currently serves as assistant professor and head of the Department of Mathematics and Statistics at CT Bora College, affiliated with the Savitribai Phule Pune University. Dr. Kale completed his PhD in applied mathematics from Defense Institute of Advanced Technology Pune, where he focused on fictitious domain methods for solving complex elliptic and parabolic problems, with experience as a postdoctoral research associate at the Indian Institute of Science, Education and Research. He has contributed significantly to high-performance computing project related to cardiac electromechanics under India's National Supercomputing Mission. His extensive research portfolio include several publications in a reputed journal and numerous presentations at international conference. Dr. Kale's expertise extend to machine learning, image processing, and algorithm developed, making him a versatile figure in both academic and applied mathematics. I hope that his expertise in the domain will really benefit to all the participants. Now, I would like to welcome our resource person, Dr. Kale. Dear Professor, welcome in this session and over to you.
Yes. Thank you so much, sir, for such a wonderful introduction, and thank you for giving me an opportunity to present myself in the faculty development program in such a wonderful event. So I'll start it. I'm sharing my screen.
Sir, your screen has been shared perfectly.
Am I audible, sir? There was
Yes, sir, audible.
Sorry, there was some technical issue. I'm sharing my screen. Yeah. Is my screen visible?
Yes, sir.
Yeah. Yeah. Today's topic of presentation is advanced programming techniques in MATLAB. So I will start presentation. So this is the outline of my presentation. First, I will introduce MATLAB, a basic structure. I will introduce some script files in MATLAB. Then I will introduce some arrays and basic functions related to arrays, and then basic elementary functions in MATLAB. I will introduce some user-defined functions, function handles, and anonymous functions, and some operations related to function handles. Then I will also introduce some debugging techniques to your code. Then I will add on some control flow statements in MATLAB. And finally, I will conclude my session. First of all, MATLAB, as we know that it is a computational software and it comes from mathworks.com. And it is very easy for algorithmic development compared to the low level language like C, C++. It is a very handy, and the MATLAB word comes from two words named matrix laboratory, and it is a high level language, and it has specialized toolboxes for making things easier, like it has special toolboxes for image processing or fluid mechanics, like that. So this is the window of MATLAB. For example, this is the MATLAB. This is a 2018 edition. So this is the command window where you can do several operations such as 1 plus 2. This is the command window. This is the editor where you can write your script files. This is your workspace where you can see which variables are there stored, and here you can see the files. It is a current folder. Then, if you require any help in MATLAB, you can just type help and on some topic. Suppose I want to type, I want information about inverse of a matrix. I will just type help inverse INV, and then it will give so much information to me in command window. So this is the help function. Then in MATLAB, you can do many things in command window itself, but whenever you want to write large codes, then there comes a need of writing a script files. Then how to write a script file? Just open a MATLAB, then go to here new, come to your script button, write your own code, and write here some code. Suppose A equal to 1, B equal to 2, and C equal to A plus B. This is your code. Suppose you just have to save it here, save as, and with some extension, .m extension. Suppose I will save this like this only, and then I will run this code. I will get the output of this code like this. Then we have seen how to run the script file also. We have seen the output. Then before going to the directly to the functions, firstly I will introduce arrays in MATLAB. In MATLAB, in fact, every variable or anything comes or stored in the vector form or matrix form. So array is a collection of data values organized into rows and columns and known by a single name. Arrays are fundamental unit of data in MATLAB. Scalars in MATLAB are also created as arrays of one row by one column dimension. Rows and column indices of arrays start from 1. As you know that in C or C++, your indices starts from 0, but always remember that the starting point or indices in MATLAB starts from 1. Arrays can be classified as vectors and matrices. Then vectors are array with one dimension, matrix array with more than one dimension. The size of an array can be specified as the number of rows and number of columns. Then some notes about variables in MATLAB. All variables in MATLAB are arrays. The scalar is an array with one element, and also in MATLAB there is no need to define the size of an array before the elements are assigned. Like whenever you write a code in C or C++ or Fortran, you have to always specify the elements or variables before using it in the code. Again, you also have to specify the type of the element, whether it is integer type, float type, that or double type. You have to always specify before using it. But in MATLAB, you can directly assign the value to a variable before declaring it prior. Then, once a variable exists in a MATLAB, it can be in a scalar, vector, or matrix, and the changes in variable are made in background of MATLAB are made in the arrays, in adding some elements or elements to those arrays corresponding to those variables. And this is the major advantage of MATLAB. You can declare the variable anywhere in the code and you can use it at the time. Then initializing variables in assigning statements. Arrays are constructed using brackets and semicolons like this. Suppose this is a matrix. Suppose you have to write any matrix. Suppose I want to write a matrix A equal to 1, 2, 3. I will give in order, this is the first row. In order to go for second row, you have to give a semicolon. Then 3, 4, 5. Then 6. Here you can give comma or not. It is optional. Completely option 6, 7, 8, and this becomes a matrix for you. Then the expressions used to initialize arrays can also include algebraic operations and all other portions previously defined. In fact, in defining arrays, you can include some algebraic expressions also. Now, how to initialize arrays? There are some shortcut expressions. For example, you have to initialize the array name x. Here it gives x equal to from initial value to final value. It will give like this. Suppose x is my vector. Here, my first element is 1 and last element is 10. X equal to 1 to 10. It will give me 10 elements like this, where gap between each element is 1. Suppose I write this x equal to 1, 2, and the gap between I want 0.5 only, and then 10. Thus, it will be now 20 elements, and the gap between each two consecutive elements is 0.5. Similarly, this initial value, in between I'll give increment, and then I'll get final value. Then linspace is a very useful command in MATLAB. Let's say I want to create a vector x equal to linspace 1, 2, 1, 2, 2. Oh, this is giving error. The command for linspace is linspace start number, end number, and number of entries you want. Here, linspace 1 to 10. This will give linspace 1 to 10. This is give by default 100 entries it will give. But if you want to specify the number of entries, suppose I want only 5 entries, it will give 5 numbers in between 1 to 10, and they are equally spaced. Suppose I want 20 elements, then I will give here like this. Then there is again log space command similarly, and it is given logarithmically spaced row vectors. Same. Suppose I want logarithm space vector log space x equal to log space 1, 2, and the gap I want 0.1 and 3. It will give like this 3 entries, and between 1 and like this. So again, suppose I want to construct a matrix. Suppose I want to construct a zero matrix of size 3 by 3. This simple I will give x equal to zeros of 3. It will give me a 3 by 3 matrix of zeros. Suppose I want a 3 by 4 matrix of zeros. I will give zeros of 3 by 4. Here I will give a 3 by 4 matrix of zeros. Similarly, for other dimensions also. Suppose same you can do here zero matrix of any size m by n. Suppose I want a random matrix of size m by n. There is a command random matrix RAND. Suppose I want a random matrix of size 3 by 4. It will construct a random matrix of size 3 by 4, and the entries will be between from zeros to 1 like this. Suppose I want a random matrix of size 3 by 4 only, and the entries I want between 1 to 10, then I will simply give 10 times random from 0 to of size 3 by 4. Then I will get a random matrix of like this. Suppose I want an identity matrix of size 3 by 3, then simply let's say I be identity matrix and of size 3 by 3, I equal to EYE. EYE is a MATLAB inbuilt function to generate a identity matrix. Then I will get a identity matrix. Suppose I want a diagonal matrix whose every entry is 5. Then I will give, suppose let D be a diagonal matrix whose each entry is 5 on diagonal, and it is of size 3 by 3, 5 times E by E of size, let's say 3. Then here I'm getting a diagonal matrix of size 3 by 3, where on diagonal there is 5. Similarly, identity matrix of size m by n also you can get. Like suppose I will type identity matrix of size 3 by 4. I will get a matrix like this. I will clear all of my workspace and clear my screen. Then suppose I want a matrix whose all entries are 1. Then I will simply command of, suppose I want a matrix of size 1 of size 4, 1 of 4. I will get a matrix of size 4 by 4 whose every entry is 1. Suppose I want every entry of matrix to be 5. I will give 5 times 1 of size 4. Every entry is 5 like this. Similarly, suppose I want to find inverse of a matrix. Let A equal to 1, 2, 0, 0, 1, 2, and 0, 0, 1 be my matrix. And if I want to find inverse of this matrix, I will simply do, there is a command inv of A. This will give a inverse of my matrix. You can see here A into inverse of A will become identity matrix. So inv is a inverse of my matrix. Then suppose you want a power of a matrix. Let's say A is this matrix out. Suppose I want the square of this matrix. I will simple A raised to 2. I will get a square of matrix. Suppose I want third power, like this. You can take as much power as you want. A raised to 20. Here you will get the power of matrix. Then suppose we want a determinant. Let's say by clicking on the button page up, you can take the previously entered command. Let's say A is this matrix, and suppose I want determinant of this matrix A. Then I'll simply do DS command determinant of A will give determinant of this matrix. I'll get determinant of this matrix as 1. As you can see, this is the upper triangular matrix, and eigenvalue of this matrix is 1 1 1, and determinant is 1. So determinant of this matrix is 1. And then again, suppose I want eigenvalues of this matrix. I will simple. There is a command EIG of A will give eigenvalues of this matrix, and you can see eigenvalues of this matrix as 1 1 1. Suppose I want eigenvectors for this matrix. Let's say D be a matrix, D be a diagonal of entries of all these matrices. Then D is a diagonal entries. Then for eigenvector, let V be our eigenvector, and D be a diagonal matrix of a given matrix. VD is equal to EIG of A will give eigenvectors for our matrix. So here you can see 1 0 0, 0 1 0, and 0 0 1 are the eigenvectors for our matrix. Then suppose there is an already available matrix. Suppose let this be a matrix, and you want to extract the size of this matrix. Then then there is just a command size of matrix A. Size of A is a command. You will get size of A is a 3 by 3 matrix. Let's say suppose our A is like this 0 2 4. Now A is a 4 by 3 matrix. Then size of A will give 4 by 3 matrix, 4 rows, 3 columns. Then let's say you have a vector x equal to 1 2 3 5 6 8, and you want length of this vector. You want to find the length of this vector. There is command length of x. It will give length. See here 6 entries are there, so length of our vector is 6. Similarly, you can use here size command for x2. Then you will get 1 row and 6 columns. So x, and similarly size of x prime means transpose will be 6 by 1. Then length of for a matrix. Let's say your A is this matrix. Here A is a 4 by 3 matrix. Okay. Then what will happen if you use length command for matrix? It will give the highest number between the number of rows and number of columns. Let's see. Let's say length of A. There was a spelling error. So length of A is 4. It is, and size of A was 4 by 3. So length is the highest number between the number of rows and number of columns. Then similarly, as we already seen, let's say A is a matrix, then A transpose will give transpose of a given matrix. See here, size of A is 4 by 3 and size of A prime or A dash is 3 by 4. So in order to find a transpose of a given matrix, just for a given matrix A, you want to find transpose like A dash, it will give a transpose of given matrix. Then suppose you have two vectors. Suppose you have two vectors x equal to 1 2 3 4, y equal to 4 5 6 7, and you want to find dot product of these two vectors. There is just command dot of first vector comma second vector, dot of first vector comma second vector. You will get dot product of these two vectors. Suppose you want to find a cross product of 3 by 3 vectors. Let's say now let's say x1 is equal to 1 2 3, x2 or y1 is equal to 5 6 7. Then you want to find cross product of these two vectors. There is just a command CROSS of first vector comma second vector. Then you will get cross product of these two vectors. Then, as already explained, the matrix indices in MATLAB starts from 1, not from 0, as in C. For example, here let's say x is this one. Here x of 0 will not give any output. See here x of 0 is giving error because in MATLAB entries start from 1, but x of 1 will give, sorry, x of 1 will give entries like this, and let's check what x of 0 will give. So see, x of 0, array indices must be positive integers or logical values. Means the numbering in MATLAB starts from 1. The numbering starts from positive integer. That means 1. So x of 1 here is first entry is 1 in x. X of 1 will give output, but x of 0 will not give output because in MATLAB entry starts from 1, not from 0. And again, the matrix indices must be positive integer. Similarly, because here as our, let's say x1 was this, and x1 of 0 will get error. Similarly, x1 of -1 will also give error because in MATLAB there is a compulsion that our indices should be positive integers or logical values. Clear all is a command to clear the workspace, and CLC is a command to clear the command window. Now, to address the entries of an array with a colon, let's say, suppose here A is this matrix. I will run this code by pressing F5. So here A is this matrix. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And suppose I want to extract second row of a matrix. I will give A of 2. Second row means I want second row and I want all the columns corresponding to it. So let's see. So this should give output 5, 6, 7, 8. So the output of this is 5, 6, 7, 8. Suppose I want third row. Similarly, I will do like this 9, 10, 11, 12. Again, suppose I want the first column of this matrix. That means I want all the rows corresponding to first column, and I want first column. So A of colon comma first column, it will give output 1, 5, 9. See here. Similarly, suppose I want the third column like this, it will give a third column. See 3, 7, 11. Okay. So with the help of colon, you can extract all the needful entries. For example, here you have extracted second row of a matrix and third column of a matrix with this code. So this is the script file for a code which I have written, and the extension of this file should be .m file. It will indicate to MATLAB this is the MATLAB file. Then suppose there is a vector, let's say x equal to 1, 2, 3, 4. This is a vector. Suppose I want to add fifth element to this vector, then how to add it? So for that, here is a code. Let's say, then you can add x equal to, suppose I want the previous entry should be as it is, and I want fifth entry should be, let's say 100. Then your x will look like this here. This is the previous x, and this is the new entry 100. See here previous x, and this is the new entry 100. Similarly, suppose you want to add, now let's consider our x is this one. Suppose I want to add 200 at the beginning of this x, then I will say x equal to 200 and x like this. You can give comma or ignore comma, there is no issue. So see here, our previous x was 1, 2, 3, 400, and now it is updated to like this. So see here, suppose this is a code written for to study how to add elements to the existing vectors or arrays. Let's clear my all the workspace, and I will run this vector. Let's say v equal to 10, 20, 30. Here 40 is added here. Oh, what happened? I will run this code and see my previous v was 10, 20, 30, and then it becomes v 40 and 50, 60. So your v should look like this, see here, 20, 20, 30, 40, 50, 60. Suppose I want to add it at the beginning, so this is the code. And suppose I want to add the entry at the specific position. Let's say u be a initial vector, u is equal to 1, 2, 3. And let's say I want to add at the position 2 the entry 10, means I want 1, 10, 2, 3, and again I want to add at the position 3 like these elements. Then initial u was 1, 2, 3, but now our final u is like this. See here, 1, 2, 3 is there. This at the second step 10 is added here at position 2, and at position 3 this vector 20, 30, 40 is added. See here, 20, 30, 40 is added here. I will share this code to you later and you can study by playing around these codes. Then adding elements to a vector is done. Then similarly, addition and subtraction of arrays, it is a very simple. There is nothing. Let's say a equal to 1, 2, 3, 4, b equal to 6, 7, 8. Let's insert 2 by 2 matrix. Then suppose I want to do a minus b, just do a minus b. If you want to add, do a plus b. And if their size is compatible, if you want to multiply, just do a star b. Then we have seen addition of two vectors, or let's say x equal to 1, 2, 1, 2, 3, 4, y equal to 6, 7, 6, 7, 8, 9. Then x plus y becomes again a vector. Okay, addition of two vectors, then corresponding entries are added. But let's say my a be a scalar whose value is 100 and my x is 1, 2, 3, 4. What will happen if I added 100 to the x? Let's say x plus 100. So see here, 100 is added to each entry of a given vector. See here, 100 is added to 1, it becomes 101. It is added to 2, it is becoming 102. Similarly, 3 is becoming 103. 4 is becoming 104. So addition of a scalar to vector, the scalar gets added to each individual entry of a vector. Similarly, matrix multiplication. If matrix size are compatible, then there is no issue. Okay, means if, as previous example, here A was 2 by 2, B was 2 by 2 matrix, then in matrix multiplication there is no issue, it is fine. But if the size is not compatible, let's say A is equal to, now I will modify the variable A equal to 1, 2, 3, 4, 5, 6, 2 by 3 matrix, and here this is a 2 by 2 matrix. Let's try multiplying A star B. So there is, it is giving error in incorrect dimensions for matrix multiplication. But let's check B star A. So B star A is compatible because B is a 2 by 2 matrix and A is 2 by 3 matrix. B is 2 by 2 matrix, A is 2 by 3 matrix. So B star A is compatible, but A star B is not compatible. So for A star B, MATLAB is giving error, but B star A is working fine. So done. Now indexing and slicing arrays in MATLAB. Okay. So here I have written a code for indexing and slicing. Let's run first, clear all the variables. So here my B is this matrix, and suppose I want to extract this element 2, means first row second column element. Then I will just do B of 1, 2. It will give me value 2. Here first row second column entry first row second column B of 1, 2 is giving value 2. Suppose I want to extract first column of this matrix, then B of all rows first column, as explained before, this is giving like this. Suppose I want third element of this vector. What will be, just suppose let's say B of 3. what output it will be of 3 is 7. Let's see here. It is going column wise 1, 2, 3. It is going column wise. Similarly, B of third row, first column will be output 7. So you can extract the elements from arrays, vectors, or matrices as you want. Suppose, let's say here A is this vector, and I just want elements 2 to 6, 2, 8, 6. So here 2 is the second element, 6 is the third element. So I will just do A of 2, 2. This is 2 is the second element and 6 is the fourth element. A of 2 to 4. It will give me value 2, 8, 6. Many times in scientific computings, you require just ending element of a vector. Suppose I want end element of a vector, just A of end, it will give value 10, means A of 10, correct? Suppose in some cases, it may happen that you do not know size of a given array and you want to extract the ending element of a given array. You can just type the array and the ending element. Let's say I want ending element of array B. B of end is 9. Let's say what was that? C here. Ending element B is 9. So it is B of end is giving value 9. Am I clear? Okay. So indexing and slicing for 2D arrays are also completed. 1D arrays is also completed. Now we have seen up to this case, we have seen almost all the functions to play around 2-dimensional arrays. But in some cases, it might require you to consider multi-dimensional arrays, means matrices of size more than 2 dimensions. Means suppose you want to consider a matrices of size 3 dimension, what will happen? So it will a multi-dimensional array or 3-dimensional array is the first, it is a considered as a extension of a matrix to more than 2 dimensions. For example, 3-dimensional array can represent a stack of matrices. Means here you can see this is a 3-dimensional array. First stack is itself a matrix, second stack itself is a matrix, and third stack itself is a matrix. Just this like a nth dimension. For example, here I have written a code array for multi-dimensional array. Suppose you want a 3 by 3 array, 3-dimensional array of 3 stacks, and in each stack there are 3 rows and 3 columns. Let's say I want, and all entries zeros. I will consider zeros of 3, 3, 3. Then it will give me, see here. Here it is a first stack whose matrix is all entries are 0. This is a second stack whose all entries are 0. This is a third stack whose all entries are 0. Suppose I want a matrix with 4 stacks and each stack contains, let's say, a 2 by 3 matrix. Let's type zeros of 2, 3, 4. So see here, each there will get 4 stacks, 1, 2, 3, and 4. We are getting 4 stacks, and each stack itself is a matrix of size 2 by 3. See here, 2 by 3. Each stack will be a matrix of size 2 by 3, and we'll get such 4 stacks. First stack, second stack, third stack, and fourth stack. And you can give the values to stacks manually also. For example, if we run this code, see here. Firstly, I will introduce A of zeros of size 3, 3, 3. I have defined manually first stack as a matrix of size 3 by 3. See here, this is a matrix of size 3 by 3. Again, second stack, this is a matrix of size 3 by 3. Third stack, it is also a matrix of size 3 by 3. See here, suppose I run this code. See here, my entire 3D array. See here, first stack is a 3 by 3 matrix sum. Second stack is some matrix. Third stack is some matrix. And similarly, the first slice, the slicing as we have done for 1D array and 2D array. Similarly, first slice is this one, second slice, and what happened to this? And similarly, you are getting third slice. And element, suppose you want to extract the element at the position. This means that in a first slice, I want element in the second row, third column. See here, it is giving 6. See here, in a first slice, remember, first slice, in that second row, third column. See here, in a first slice, second row, third column, it is a 6. This is a first slice, second row, third element is 6. It is given. Similarly, if you want in a first row, first element in a third slice, it should get 19. It should get 19. Let's check what it's giving us. See here. In a third slice, first row, first column element is similarly A of, suppose I want second row, third column in a third stack. It should become 24. Let's check. See here, it is giving output 24. I'll clear my screen. So this was all about multi-dimensional arrays. Here we have seen 3-dimensional arrays. You can also define arrays with more than dimensions 3. Now we'll start basic elementary functions in MATLAB. So this is a very basic things. There are obviously addition, subtraction, multiplication, and division are basic elementary functions, and symbol for a plus, minus, into, divide. Suppose 1 plus 2, 3, 3 minus 4 minus 1, 3 into 9, just give a star, 27, and 9 oblique 9 divided by 4, it is giving some value like this. See here, we never specified whether 9 is integer or what output will be. See here, in C you have to specify the type of output you want. Here I did not specify, as we all know that 9 by 4 is a fraction, so by default it consider output is in a float mode. And again in MATLAB, the recently available variable or answer is stored in a variable named answer. Answer will be given like this. Answer is the recently available variable. Then there are some basic trigonometric functions like sine, cos, tan. You can directly, suppose I want sine of pi, for pi there is a pi. Suppose I want sine pi by 2 is 1, sine of pi is 0, means see here. Now sine of pi should become exactly 0, but in MATLAB it is approximate value. It is up to e raised to minus 16. It is means nearly equal to this 0. Let's check sine of 0. Sine of 0 is exactly 0, but sine of pi it is giving e raised to minus 16, means 10 raised to minus 16 accuracy. Similarly, for cos of pi, it is giving minus cos. Similarly, for tan of pi by, let's say, pi by 2, it is giving value like this. I think it is going to infinity. Tan pi by 2, let's say tan pi, it is giving to 0. It's a pi by 3. It is giving value like this. Tan. Similarly, cot of, there is nothing special here. See here. Similarly, all sine, cos, tan for all the trigonometric functions. Then exponential logarithm function. For exponential in MATLAB, variable e directly is not there. Let's see here. See here. If you type e, it is giving error undefined function of a variable. Suppose you want to value of e, then there is a command exponential and exponential of 1. It will give value 1. See 2.7183. Similarly, exponential of 4, it will give e to the 4. It is giving e to the value 4. Correct? Similarly, exponential of minus also it will give like this. Suppose I want to find 2 raised to 3. Just type 2 raised to 3. It will give 2 raised to 3. Suppose I want to find square root of 4. There are 2 ways. I can do 4 raised to 1/2 4 raised to 1 half or square root, or I can do square root of 4 like this. Also, I can take any fractional power of any or negative power. Suppose I want negative power for 7 minus 1 by 10. This also is achieved. Means any power you can take. Similarly, there are logarithm function, log function. Log is for natural logarithm. See, log of exponential of 1, it will give value 1. Correct? Similarly, log of exponential of 2, it should give value 2. It is correct. So, log is a command for natural logarithm. But what if you want to find a logarithm with respect to base 10? Then there is command log with respect to base 10, as this 10 should come value 1. See here, log of 10 to the base 10 value is 1. Similarly, log of 100 with the base 10 should become 2. So log 10 is a command to obtain logarithm with respect to base 10, and the simple log gives a logarithm with respect to base e. So log of 1, 2, 3, it is giving logarithm with respect to base e, and log with respect of the same 1, 2, 2, 3, this will give value this like this. So log is the natural logarithm, this log is a natural logarithm, and this is the logarithm with respect to base 10. Similarly, power and square root functions we have already seen here. Absolute value and sign function. Let's say let my number is equal to 4.1, then absolute value of my number, to find absolute value, it will give like this. So this is giving absolute value. Let's say my number is negative. Let's, for example, suppose I want to find absolute value of minus 2. See here, it will give value 2. So to find the absolute value, there is a command called ABS. For example, ABS of 100 is 100. ABS of minus 100 is also 100. Now, suppose you want to find a floor function, ceiling function. See, for example, floor of 1.3 will become 1. Similarly, ceiling of 1.3 will become 2. Floor function and ceiling function. But floor of minus 1.3 will become minus 2, and ceiling of minus 1/3 become minus 1. Then what if you want to find a number towards 0? Then there is a command, see here, fix of minus 1.3 value is minus 1. Again, fix value of 1.3 is 1. It is coming toward 0. But see here, ceiling of 1.3 is 2, and fix of 1.3 is 1. So you can use 3 functions, fixing, ceiling, and floor function in MATLAB effectively. Then these are the rounding functions in MATLAB. Again, there is a command to round function. Suppose what happens if you do round of 1.3. See here, it is giving rounding numbers. Let's say this digit is greater than 5. See here, round of 1.7 is 2. However, round of 1.3 is 1. So here you can round up the number, find the floor function, ceiling function, and fixing function also. Suppose you want to find sign of a given number. There is a function called sign. Sign of 1 is, let's say sign of 100 is 1. Again, 1 is for positive. Sign of minus 100 is minus 1. Similarly, sign of there is nothing. Sign of, see, it is just giving a sign. Means if number is negative, sign function is giving value minus 1. If the number is positive, sign function is giving value 1. rounding function done. Then for trigonometric inverse, there is a just function arc sine for a sine, a cos, and a tan. For example, suppose you want to find inverse of 0, a sine of 0, arc sine of 0, 0, a sine of 1, it is giving 1 like this. I think it is in degree. So there is a function. Similarly, a cos will also work for cos inverse, a cos of 0.5, it will give like this. Similarly, a tan will also work. See here. So for this, for trigonometric inverse. Then for hyperbolic functions, sin h, cos h, tan h are there. Sin h of 1 is this, cos h of 1.2. Similarly, tan, or let's consider cot h of 2.3 is giving this. So sin hyperbolic, cos hyperbolic, cot hyperbolic, there are functions. Built-in functions are there in MATLAB. Now, scripts and functions in MATLAB. Now, this is the very important topic. In order to write a large codes in MATLAB, whenever you want to write large codes in MATLAB, there becomes a need to write functions in MATLAB. Most of the times, what happens, for everything you cannot write in a main script file. There will be a main script file, and for each individual operation, you can write a separate MATLAB files. You can define a separate functions for each MATLAB file, and you can call those functions in a MATLAB. So you already know how to save a script file, how to run that file. Now, in order to give a nomenclature to the file, you can write a program in ordinary text file giving a suitable name such as myfile.ym to a script file. Okay, but what if suppose you want to give a name to a file which is already some keyword in MATLAB? Then it is a problem. Then for that you have to check whether whether that name is there in keyword. Suppose, for example, there is command which is a command to check whether that is a keyword or not. Suppose with sum. Suppose you are writing a script file to add two numbers. So you should not give a name to your script file sum.ym, because sum is a keyword in MATLAB. Okay. If you give a name sum to your file, what will happen? It will not consider sum as the MATLAB keyword. So that facility you will get lost, because that sum function will not work, because the name sum you already used for your file name. See here, sum.ym does not turn out to be a good option to a file name. As you can see, sum is a built-in option. So if you use sum.ym as your file name, then you will not be able to use the sum command provided by MATLAB. Means sum command is for MATLAB. So let's say x equal to 1, 2, 3, 4 is my vector. Suppose I want to add all the entries of this vector. There is a command sum of x. It will give me sum of all the entries. See, 4 plus 3, 7, 2, 9, 1, 10. Sum of all the entries. But if I used sum to name my script file, for example, let's check. Right now only we can check. Let's say a script file. I will write something whatever is equal to 1 as a script file, and I will save this file as sum.ym. In the same folder, let's check what happens. See here, it has given a lot of warning that now you cannot use sum as your function. Let's clear the screen and let's now check. Now let's check which sum. Let's see here. Now it is not giving sum as a built-in function. Now it is giving sum is the file. Sum.ym is a file in your folder. Now our x is this vector. Now let's try sum of x. See here. Now this is not working. So while giving a name to your script file, always take care. You should not give a keywords of MATLAB as a name to your file. See here. Previously, you could use sum as your keyword, but for finding sum, but now you cannot. In order to use, now I have to delete this by going into, suppose let's check. I will go into that folder. I think it will take time. If I delete that, let's check. I will delete this folder here, and now I will check which sum. Again, here it is given, it is a built-in function. Now let's check x equal to 1, 2, 3, 4, and let sum of x. Now sum of x is working. So the moral of the story is you should use the names of your files very, very wisely. You should always take care in order to give names to your files or functions. Now, how to write a function in MATLAB. The first line in a function file must begin with a function definition statement, which lists the inputs and output of the function. See here, in order to define the function is a keyword, then what are my output variables, and then what is my function name, and what are my input variables. Again, the statement distinguishes a YUM file from the script YUM file. Means with the help of this statement function, the MATLAB gets to know that whether it is a script YUM file or function YUM file. So in order to write a function, this function command is very useful, because if you don't use this, MATLAB will not get to know this is a function file. It cannot get to know whether it is script file or function file. Now, again, the output variables are enclosed in square brackets, except when there is a single output. If there is a single output, then this square bracket is not necessary. But if there are more than one outputs, then this square bracket is highly necessary. Then, if there is no output, you can leave the output field blank as follows. If there is no output, see here, there is no any output, and there is just function name and input variables. Now, simple addition function. Here, see here, function. This function is defined function whose name is result. This is the output, and function name is add numbers AB, and my result output variable will be A plus B. And again, in another script file, I will give. Now here sum is my variable name. Okay, is a add numbers. This here, this add numbers is my now a user defined function which I defined. Its inputs are AB. See here, I will get input 3, 5, and then I should get value 8. See here, now sorry. Now here function add. Okay. So here, see here. Here you have two choices. In a simple code, you can write the function at the bottom of your code, and you can call the function at the top of the function. See here. So suppose I will run this code, I will get for here add numbers 3, 5. I am getting value 8. Suppose I change number 4, 5, 4, and 20. I should get output 24. See here. Now, suppose now this function at the bottom should be there. Many times what happens, by mistake it comes to the top, then it will give. See here, now if you run, it will give error that function end is not proper. So this function should be at the bottom. Then I will check whether it is running. Yeah, it is giving output 24. So like this function, and again there is another option. So in actual problems, one should define the function in another folder. Let's say here it was a small function, so it was fine. I will cut from here, and I will write a new script file for my function. And again, while saving, take care. The name of your file should be of your function only. The name of file should be add numbers.yum only. If you do not give the same name as a function to your file, it will give error. So I will save as this as add numbers with see here. MATLAB will automatically track it or detect it. See here, it is giving same number. I will save it now. Again, here was my function. See here. Now add number. This is a function which I saved in another script file, and here I am just calling this 2-line code. Still it will run. See here, 4 and 20. Similarly, 1 and 2, it will give output 4. It will give output 3. See here, it is giving output 3. How this is happening? Whenever you are writing this add numbers, it is going to that the same folder, and see here, see there, search there whether there is a file add numbers.em is there or not. So it is taking output from there. So like this. So for single output, it was like this. Suppose you want multiple outputs, then you have to write your output in a square bracket. Same here. Suppose I want a multiple output, so I have written up first see the function. Then here we are calling the function. But important is see the function. Here I have two outputs, sum and product. The name of my function is sum and product. It is a name given by user. It is given by us. You can give different name also, but the same name you have to call here. The sum and product and input are AB. If I give input AB, it will store A plus B in sum and A star B in product. So first I'll clear my all variables and I will run it. See here, sum of 3, 5 is 8 and product of 3 and 5 is 15. We are getting. Similarly, if we click here, let's say 13 and 5 will get 13 plus 5 is 18 and 13 into 5 is 65. Now, functions with conditional logic. Suppose you want a function where there are logic statements with some if statements are there or some while or whatever loops are there. You can also write. Suppose you want to check a number, given number, whether it is positive or negative. So for that, I have written here a function. So see here, conditional function. See a function whose output is stored in the variable result and input is x, and check number is my function name which I have called here. And if x is greater than 0, I will store my result as positive. If x is less than 0, I will say my result is negative, and else neither positive nor negative, I will consider result as 0. See here, input number is -3, so I should get output as a negative. See here, the number is negative. Here this command, the number is a string and this is a variable. The number is negative. Suppose my number is positive plus 3. Now output is the number is positive. Suppose my number is 0. The number is 0. And again there is a trick. Suppose I write here anything. Let's check. Suppose I just write ABC. Let's check what happens. See here, it is giving error because the input is a number. So let's again run. Let's say 100. Then my number is positive. I'll clear all the variables. Okay. Now, suppose this is a user-defined dot product function. In MATLAB, there is also predefined dot product function. Let's check how to do dot product user with function. I have written a function. The output is stored in result, and the function name is dot product of vector 1 with vector 2. See here, if length of vector is not equal to length of vector 2, it will give error. Vector must be of the same length, and if not, result will be sum, and it is a component wise or dot multiplication here. See here, suppose my v1 is 1, 2, 3, v2 is 4, 5, 6. These are my input parameters, And here dot product, here inputs are given here. Let's run. So dot product is 32. Suppose their size is different. Size of V1 is 3 by 1, and let's say size of V2 is 4 by 1. Let's enter here element 3. So it will give what happened. It's here. Error vectors must be of the same length. It has given the error. See here. Error is the, now this is also error which is defined by the user. Because vector must be of the same length. I suppose I add here something crazy thing. Do it right. Now it will give the same error. It will add do it right also here. Let's check what happens. Let's check. Let's play around it. To learn the MATLAB, one just play around it. See here. Now error, it is giving vectors must be of the same length, and the craziest part also do it right. So error in this function. So you can also write error codes for your function. Again, it will turn dot product is 32. Now there are some statistical again, one thing I want to clear. Suppose you need one should always prefer user defined. For example, here I'll first run this. Here let's say V1 is equal to this one, V2 is equal to this one, and their dot product, the dot product was 32, and this is the function defined by us. But in MATLAB, there is already a dot function. So one should always prefer that, but I think it will not work here because now see here again. Previously, you have already used the dot function, but now it is not working. Why? Because the keyword dot of MATLAB, which is used here to save a variable. So now dot, it is not allowing us to use it. Okay. Now let's clear all the variables in workspace and then check what happens. Let's say V1 equal to 1, 2, 3. V2 is equal to 4, 5, 6. Now dot function will dot of V1 comma V2. Now dot function is working. But if you run this code, and now if you want to use dot function, now it will give error. Why? Because here the keyword of MATLAB, here you went, because here the keyword of MATLAB you used here as a dot. Suppose I give here the variable dot 1 and here dot 1. Now let's check. See here again dot product is 32, but now I can use the keyword. Let's now check what will happen. Dot of V1 comma V2. Now still it is not working. Again, I think dot is still used somewhere. Dot 1 dot product. Okay, let's clear all. Then let's check dot of then I want V1, I want V2, and then dot of V1 V2 is working. Okay. Now then another topic is function handles and anonymous functions. We have seen in order to define the function, there is some procedure, and sometimes it is lengthy one. Sorry. Then in order to define the function or user-friendly function as a function handle, you can define function handles like this, which I will explain. Function handles and anonymous functions in MATLAB are powerful tools for writing compact, flexible, and reusable code. Function handle is the MATLAB data type that represents a function. It allows you to pass function arguments to other functions and store them in variables. Means here functions are stored as variables and they are called here dynamically with the help of the add operator. See here. Now here f handle function is defined for as @ sign, and you can as f handle of pi by 2. Instead of using sign, now sign will be get transferred with the help of this add rate operator to a function called function handle, f handle. And now even if you give input argument to a handle function, it will work. See here now, here is happened function handle. Okay, see here for this code, f handle is equal to sign. See here, it is result of f handle of pi by 2 is 1, because f handle is of for sign. So f handle of pi by 2 is 1. Similarly, as we know that sign pi should be 0. Now let's f handle of pi is becoming 0. See here, e to the minus 16 means nearer to 0. Let's check. Okay, let's check here 0. Sign of 0 is 0. So f handle of 0 is also 0. Again, let's check here add grade cos. So f handle is becoming now cos is transferred to f handle. So f handle of 0 is nothing but cos of 0. See here. But here the input is passed dynamically. So f handle of 0 is here 1. Okay. Now using here you have seen that here we have done or we have used function handle with the predefined function as sine, cos, tan. These are inbuilt functions in MATLAB, and we have used function handle to the inbuilt function. But what if we want to use the function handles for user defined function, for the functions defined by us? Then function handles can also be created for user defined functions. Now for this you have to take care. We have to define function in a separate file and save it as a myfunction.m. is here. You can give any name, but you just have to take care while calling it. Okay. Now create a function handle for user defined function. See here you have defined a my function, and in this here you have created a function handle. See, previously for this function, for creating function handle for this cos function, this f handle is a function handle for cos function, but this cos is defined in MATLAB in a background, correct? But for user defined function, your function should also be there somewhere defined in the background. So you will store your function, whatever the name of it, in the same folder. Let's say its name is my function, and here now this f handle is your name for function handle, f handle of your function name. This will create a function handle for your user defined function, and instead of passing the input x to the my function, you are passing it dynamically to your function handle like this. Let's check what is happening here. Now f handle. Okay, see here. Our my function is given here. It is firstly we have defined a function here, okay, called my function, and it is x square. And here we have defined a function handle for your function, and instead of passing value directly to the my function, you're passing this value to the function handle. Let's check this. Let's first I'll clear my variables so it should not give me trouble. All variables in what space are cleared, screen is cleared, and I'll now run my code. See here, my function is for x square, and here I'm passing input 15 to f handle. F handle is my function handle to function my function. So it is giving me square of 15. So let's check 5. It should give answer 25. See here 25. Now if I do some changes in my original function, let's instead of x square I'll do x square plus 1. Now to the same input, let's check what output it will give. It will give output 26. See here, I have done changes in my function and given output to f handle, input to f handle, and it is giving me desired output. Similarly, x square plus 100 or whatever, or I will do cos of now I will use here predefined function plus cos of x, and I will give here output 5. See here, something it has done. Okay. Or here, let's say 0. So 0 square will be 0 and 0 square will be 0 and cos of 0 will be 1. Let's check 1 is coming or not. See here. Result using user function is 1. Done. So you can use function handle to user defined function also. Now, anonymous function is another powerful tool, or it is a way to create a quick, simple function without having to define in a separate file. Now, they are particularly useful for short functions that are used only once or twice. In order to save time, if you want to define function for a short time, you can use anonymous functions. Then, in order to create anonymous function, again it is created with the help of operator @ followed by a list of input arguments and a function expression. Now see here again. Here, this @ will help MATLAB to get to know that this X is the input. This @ will help MATLAB to understand that this X is input. Sorry, this X is for input variable and this is my function. See here, previous functions were looking like this. See where it went. Previous functions were function give function, then give some output, then function name, some input, again define here for some function, and then again. So the anonymous function will is your task. See here, simple, the name of the function. Here @ will understand the MATLAB that this is the input and here output. Done. So square function is for square function of, so see here how small it is. So here anonymous function, see here, @ is input, it is the output function, and it is input passing through to your anonymous function, square function. First, I'll clear my all variables in workspace. See here, output should be 25. See here, result using anonymous function, this is a string, is 25. Correct? Suppose I will change the input to, I'm getting 4. Suppose I want a cube, so I will do here change only x cube. See here, I'm getting 2 to the cube 8. Suppose I want to do another function for 2 inputs, let's say x y, let's say x cube, let's say x square plus y square, x square plus y square, and here 2 inputs should be passed to 3, so it should come 2 square is 4, 3 square is 9, 4 plus 9 13 should be there. See here 13. So this anonymous function can be defined for any number of inputs. Let's x y z 3 inputs, x square plus y square plus z, and let's pass another input 5, so it should give value 18. See here, it is a very easy and it is very user friendly. Anonymous functions make the codes very much user friendly, so one should always take the advantage. Again, to define more complex anonymous functions, and already you have seen here, we have seen here 2 inputs or 3 inputs to anonymous function. It is already done. Anonymous function inside other function. Anonymous functions can be used as arguments to other functions such as integration or optimization routines. See here, integral is the inbuilt integral is the inbuilt command by MATLAB, and integrand is the anonymous function. See here, this integrand is the name of your anonymous function, and this becomes anonymous function because this @ operator, your input is x and your function will be x pointwise square 3 into x and plus 2, x square plus 3x plus 2, and it will, this integral is the inbuilt function of MATLAB. So here the target is to show that the anonymous function can also be used inside the inbuilt functions of a MATLAB. Let's check. See here, Okay, this is already done. So this is already done. We have already see here. Now integrand is the name of your anonymous function. X is the input, and this is the your function defined. Integral is the inbuilt MATLAB command. First, I will before running, I will clear my all variables. See, the result of integration is this one. Okay, suppose I change the integrand from 0 to this is the syntax of integral means the syntax of integral is inbuilt command of MATLAB integral, then the function whose integration you have to find, and the starting point and end point. Let's say my end point is 2. So what happened? The bracket is required. So now my integration is this one. Suppose I will do some changes in my function. Let's say I'm adding sine of x again. So see here, we can again the code is running sine of x. Let's say I'm removing sine of x or sine inverse of x. Let's check what happens. Arc sine of x, and let's check what is happening. I will run the code. See here, the result of integration is this one. It is complex because of arc sine. Let's check only sine, and result is this one. Okay, so the output is, or you can observe that the anonymous function can be used inside the predefined or MATLAB defined functions also. Okay, now again combining function handles in optimization or using function handles in optimization. Now in optimization again, f min UNC is the inbuilt command of MATLAB for optimization problems. Again here see f handle is the anonymous function, function handle, and it is a MATLAB gets to know that it is a function handle by this @ and objective function is your user defined function. See here, this function, this is the function user has defined function whose name is objective function, whose input is x, output is y, and this y is like this, and we have created f handle for your user defined function, correct? And now you are using it f handle in optimization command. Okay, f min UNC. Let's check what's actually happening. What happened here? Okay, so this is the function. See here. Here we have defined user defined function called objective function. It is stored here in function handle with the help of @ operator, and it is used inside objective function. See here, now I will run this code. So its output is looking like this. See here, my objective function was x minus 3 square plus 4. So optimization with the help of that f min UNC command, it is giving minimum value 4 at x equal to 3. See here, this function is becoming minimal at x equal to 3. Let's change the function, or let's again see here x, I will do x minus 1 to the 4. Again, it is expected it should give minimum at 1. See here, it is giving minimum at 1 because it is a bowl shaped curve and it has minimum at value 1. You can change the objective function. Let's say I will define how was it, function was x1 variable function. Let's check what happened just for x square function. I think it should give minimum at x equal to 0. Its minimum value is 0 and it is giving at 1. Again, x x square plus 1, it will give minimum value equal to 1 at x equal to 0. Done. Okay. So the conclusion is you can use your function handles in complicated codes or even in optimization codes. Now, the very interesting combining anonymous functions and function handles. So, as we have seen, both the anonymous functions and function handles are very powerful tools in order to create user-friendly codes. Then what if we combine both the things together? See here. Here, combined function is the anonymous functions. Here, @ is used before the input variable. See, because of this @ and this input, MATLAB is getting to know that or detect that this is the anonymous function and whose output is sin x plus cos x. And now this anonymous function is stored into a function handle. This combined function is the name for your anonymous function, and you are now transferring that anonymous function into a function handle. And now next, instead of using this anonymous function, you will pass the inputs dynamically to your function handle. See here, your original function is sin x plus cos x. You had defined it anonymously with the help of operator @. Now, instead of transferring the inputs directly to your anonymous function, you are creating a function handle for your function, and now you are transferring your inputs to your function handle. See here, the same function, and I will clear. I will run this code. See here, function handle sin of pi by, it is nothing but sin of pi by 4. Let's check sin of pi by 4 plus cos of pi by 4. It is giving same value 1.4142. See here one, and you have used here. This is your original function, and it is defined anonymously. And instead of transferring this input to your original function, anonymous function, now you are creating a function handle, and now you are transferring these inputs to your function handle and storing the output in a variable called result. Similarly, you can do here some changes. Let's say I will add here some x cube, and now I'll try. You see here, now it is giving value like this. You can always play with this codes. Now, from all these codes, what we have observed that we have to understand the order in which MATLAB resolves function calls in debugging and function overloading. Firstly, MATLAB searches for functions in the following order. Whether that variable is in the current workspace or not, MATLAB will check. Whether that function is there in the current folder or not. Previously, we have seen if we have given a name, SUM, small SUM, to our function, then in MATLAB, you cannot use that some command, inbuilt command, because MATLAB is checking whether that function is in the current folder or function in the current file in the same nested or local function, and some built-in functions it will check. Okay, so you have to take care again using built-in functions. Again, whenever there are or whenever built-in functions are available for you, you should always prefer built-in functions. For example, this is the code. Okay, this is not there. Okay, I will. Now see here, in this code only, I have created a function in order to find a mean. Let's say function, my mean of x, whose name is my mean, and the m is equal to sum of all the entries and divided by length of that vector. It will definitely give me a mean of my vector, correct? But for example, see here, let's say x equal to 1, 2, 3, 4, 5. Okay. Now mean of x is the direct inbuilt command 3. Okay. Instead of this, you can do like this: sum of x divided by length of x. You can also do this. Okay, fine. But or you can use another tools. Instead of using this trick, you should always prefer this one. Why? Because whenever your size of x is very large, at that time, as MATLAB functions are very optimized in their way, so the computational time required for the inbuilt functions will be very less compared to your user-defined functions. So whenever inbuilt functions are always available there, one should go for that. What is happening here? In min x, it is doing, as it is an inbuilt function. Okay, so it is optimized one. But here, what is happening? Firstly, here MATLAB is finding sum of your vector, each entry, and then finding length of your vector, and then doing division. So 3 operations are more here. Three more operations have to do for MATLAB. So definitely this will take more time compared to this entry. And this will you get to know if your x is very large. Now there comes debugging techniques. Now suppose while running your code, you get some error. How to remove that error? So there are some techniques. There are many more techniques, but here I am introducing only 2 techniques because these are, I think, quite enough. Now, debugging in MATLAB is an essential skill for identifying and fixing errors in your code. MATLAB has several powerful debugging tools that help you track down and resolve issues. Here we'll see only 2. First is using breakpoints, and then second is using this function, or it is just a manual one. In fact, this is just I'm using it, or you can check it manually by just removing this semicolon. Also, you can check. So it is not a big issue. Or in fact, I use this only, and there is option breakpoints. So what are breakpoints? Breakpoints allow you to pause the execution of your code at specific lines. So you can examine the values of variables and step through your code line by line. Now, how to set breakpoint? In editor, you can set a breakpoint, which I will explain you, or programmatically you can set breakpoint. Let's check how to specify. See here, debugging first code. What happened? Debug, sample debug this, debug function. Okay, debug this code. I want some bigger function. Array multiplication, array address. Okay. Okay. So this was my code. Okay. Suppose I want to check this code, whether it is right or wrong. I will go. So suppose here I will set this. See here, red dot is appearing. So here I am telling MATLAB, here you have to stop. Correct? Suppose here you have to stop. Up to here I will check whether, see here. Here output of V should be just 10, 20, 30. Let's check. I will run this code. Here dot sign is there. It will stop here. See here. Now, see here. Now this symbol K is coming here. See here. Now my V will look like this. See here. V is my 10, 20, 30. It is stopped here. Now again here there is step option. See here. Now here, now it is stepped here and it is run. Now I will check V. Now see here, my V is now 40 is getting added to my vector. Again, here is the step button you are seeing. Again, I will go step. See here, again it is going here. Now it is run. Okay, I will also get no, it is not run. So I here is now a step. Now W is there. See here, previously W was not there. Correct. So you can go step by, you can run here code step by step. See here. And up to this, you have run your whole code. Now your whole code is run. So now you can see the output of U. Correct? Okay. Suppose you specify this line here, or let's say here. Now you can, okay, here. Now this code will run up to here only. You will get up to W. Let's first clear the workspace. Now let's check. See here. Now code is run up to here. Now you will get V like this. V is here 10, 20, 30, 40, 50, say 10, 20, 30, 40, 50, 60. 10, 20, 30, 40, 50, 60. Now W is just see 10, 20, 30. Correct? Now let's again try and run this code. I will get W is equal to, oh, it is a problem. See here, it is run up to here. Now again, I will run this code. I will get here. Now I'll check what is the W. Oh, what happened? Okay, the W is this one. C. In this way, you can check output of each line by line. So you can check the desired, whether you are getting desired output or not by running the code line by line. So this will give a opportunity to run the code line by line. Now the same thing you can do with the another option with the dbstop function. Now suppose this is your function and you want to use some, you have to stop the code at the line 4. Let's check the command for that. Debug is there, and I also want debug example for that. See here. Now I have defined user defined function, this function whose name is example function. Again see here, the name of the function is example function, and again see the file name. File name is also example function dot what happened here? Example function. Here is the debug. This is the example function. Okay. The file name is also the same example function. And suppose I want to stop the code at line equal to 4. And I am running this function. I am running this function here. My example, my function of the name of my function is example function. And I'm calling that function in another file. Both the files are stored in the same folder. So this is possible. So here I'm setting dbstop in example function at line 4. See here. I'll first clear my workspace. What happened? Just a second. Suppose in this example function, I want to stop my code at line equal to 4, and here I have called this function, and here I'm setting it 4, and my input function, inputs to my function is AB, and here now it will stop here. See here. Oh, sorry. Now I am stopping my code at line equal to 4. If I run this code, see, my input variables are 2 and 3. So at this line, I will get output in result as 4. Correct? At this line, it should be 4 into 8. And again, it should be -3 at this line. Let's run this code and check what is happening at line 4. And I will check what is output of my result. See here, I am getting output. What is happening here? Now I'll check output of my result. It is 5. Oh, what is happening? Okay. I'll run it again. Now I'll check. What is my function? Is happening. I will try without this. Let's check. At this time, output of my result is 7. Okay. So what is happening here? 2 plus 3 is 5. 5 into 2 is 10, and 10 minus 3 is 7. Correct? Here 2 plus the result is passing into here. You are passing value 2 and 3. So at this line, 2 plus 3 is becoming 5, and result is equal to 5. So 5 into 2 is 10, and again 10 minus 3, 7. So if you are not stopping, you are reaching here. Okay. Suppose now I'm stopping at line equal to 4. Then what's happening? Then my result will be 5. See here. My code is stopping here. Just result equal to A plus B. Suppose I'll run another step. Now my result will be, it should be equal to 10. Correct? Now I have run the code line by line up to here. Again, I will run here, and now I'll check my output of my result is 7. Correct? So in this way, you can check whether your code is giving correct answers or not with the help of debugging techniques. Again, there is just a second. So MATLAB pauses at the breakpoint, and at that, and there you can check that. Again, using the this function. Okay, the same thing we'll do with this function, or checking manually. This is the, you can say manual task only. Okay. Again, the same function I have defined example function, and with the 2 inputs. First, it is giving addition, second multiplication, and then subtraction of this. At this step, again, inputs are 2 and 3, correct? So at this step, your output should be 2 plus 3, 5. At this step, your output should be 5 into 2, 10, and here again it should be 7. So with the help of this result after addition is here, you can print here, and you can check whether you are getting correct answer or not. Now I will run this code. See here, result after addition, I am getting value 5. Result after multiplication, I'm getting 10. Result after subtraction, I'm getting 7. So on each line, you can print the result and you can check, or you can comment here. In fact, it was completely unnecessary. Whenever you are in actual coding, you can just remove the semicolon and you can check whether you are getting this output or not. I will see here. First, my result is becoming 5, then result is becoming 10, and result is becoming 7. So it is giving correct answer. Okay. So in this way, you can debug your code. Okay. Now there are some control flow statements. Some if statement is there. I will directly explain the codes. If statement, if else statement, switch statements are there. Then for loop is there, while loop is there, break and continue statements are there, and some nested loops or advanced things are there. I will explain all these things directly in the code. How to use if loop. Suppose if is a, suppose you want to check your number is greater than 10 or not. The syntax of if is if, and in between your some expression, and then your some code, and then end statement. Okay. Suppose I want to check my number is greater than or 10. I will run this code. Enter your number. Suppose I enter number 100, and then if my number is greater than 10, I will get number is greater than 10. Okay. I'll run, the number is, I'm getting output, number is greater than 10. Okay. I'm again running the code. Suppose I enter 2. What happened? See here, if I'm entering value 2, code is not giving any output, because this if statement is working, it is going ahead if only if this condition is satisfied. If my number is greater than 10, it is going further here. Otherwise, it is not going in this line. Correct? Because if I am entering number greater than 10, it is giving me output. But if I am entering number less than 10, I am not getting any output, because this expression is here. Okay. Again, if your statement, again, this is the syntax. So if some expression, if this expression is satisfied, it will go here. If this expression is not satisfied, it will go here. If else. So this is the code to check whether number is positive or negative. I will run the code, enter your number. This is the code to check whether number is even or odd. Even or odd. Let's type 23. The number is odd. See here. If modulus is the function, is give reminder after dividing by. See here. This modulus of your number 23 2 gives a reminder when 2 divides 23. It is giving 1, correct? So if reminder of a given number when divided by 2 is equal to 0, it is going here and it is giving the number is even. If this is not satisfied, it is directly displaying the number is odd. Again, I will run the code. I will transfer 22. So number is even. It is displayed output here only. Again, if else if same. If some condition, this condition is satisfied, number will go here. If not, then another condition, the code will enter here. If not, then code will go here. Again, I will run this code. This is the MATLAB command to check whether number is greater than or equal to 10. Let's type 20. I'm getting number greater than 10. If I'm typing number less than 10, I'm getting number less than 10. If I'm typing number 10, I'm getting number is equal to 10. So there are switch statement. So switch statements plays around case to case. So day is equal to, let's run this code. This is a code to study switch statement. Suppose switch, if that case is satisfied, switch and output of the value of that variable is satisfied, it will go here like case to case way. Suppose I will run this code and I will enter your day in string format. I will type Monday. Okay, so it is giving output start of the week. Okay, suppose I will again run the code and give the input Friday. It will give end of work week. And again, if I give any other day, let's say Tuesday, it will give middle of the work week. If it is neither Monday nor Friday, it will always give middle of the, because code is written in this way. In fact, if you run this code and type here any crazy thing, it will give middle of the week, correct? See here again, because code is written in this way. Suppose I will run and type here any crazy thing, still it will give middle of the work week. Okay, because code is written in that way. Again, I will explain some for loop. Suppose I want to do some operations on this vector z for index I is running from 1 to 5. I want to change indices of, I want to add 4 each index. Then I will run for, then some index, and then some expression and end statement. See here, I want to add 4 to each entry of this vector 10, 20, 30, 40, 50. See here, 4 is getting added to 10, 14, 24, 34, 44, 54, correct? For similarly, while loop is there. For loop and while loop serve the same purpose, but it is always beneficial or intellectual to use for loop, because while loop sometimes risky, because in while loop this line is very necessary, because if you not update your line, suppose if you remove this line or comment, okay, this code will run for infinite time, because firstly what this will do, initial my I was equal to 1, and this my code will run whenever my I is less equal to 5. As my I is not getting increasing or not getting updated, this code will run for infinite time and it may crash your system also. So always take care while running while loop. Okay, so this code should same. This is also adding the like this previous example also. It is also adding the number 4 to each entry of this vector. Same. See here, it is giving same output, but one should always, I will always suggest to prefer for loop over while loop. Okay. Again, this is the break statement you can use here. Whenever I is equal to 5, the code is stopping. It is getting exited from the for loops here. And here we're getting so after printing the output of this code, you will get to know here. You are getting iteration 1, 2, 3, 4. And as soon as I is becoming 5, the code is getting stopped. Suppose I'm making I equal to 7, then my code will stop at I equal to 6. See here. I will run this code. See here. My code has stopped at I equal to 7. If I make code this equal to 9, my iteration will stop at I equal to here. I'm getting iteration 1, 2, 3, 4, 6, 7, 8. Similarly, in the same way like break statement, you can use continue statement. See here. If again, if modulus of I means if number is even, we are skipping the operations. It is giving, it is what happened here. If number is given, it is going to this loop, else it is coming here, correct? If I run this loop, see here, I am just getting all iteration 1, 3, 5, 7, and 9. So in this way, you can use continue statement. So control statements are also done. So again, nested loops and control statement, these two parts I will then conclude. So you can use for loops inside for loops here in this way, or you can use if loop inside if loop. I will share this code, you can play around it and you will get to know more. I will run this code. See here. If I equal to 1, j equal to 1, see here. First, what is happening whenever I is becoming 1, then this will run for this I equal to 1 and it will take cases both j from 1 to 2. For I equal to 1, j is becoming 1 to 2. See here. See the output. See the output. First, I is becoming 1, and for this I equal to 1, this j is becoming 1 and 2. Again, I is becoming 2, and again for this j equal to 1 and 2. Again, I equal to 3 and j equal to 1 and 2. In this way, the nested functions. Similarly, for this, if x equal to 5, y equal to 10. If x is greater than 0, y greater than 0, both x and y are positive. Like this nested loop. So x and y are positive. Let's say x equal to -5. So it will not give output because both x and y are not positive. Okay. So in a practical life, for interesting example, suppose I want a matrix whose diagonal entries are something, upper diagonal entries are something, and I want a matrix with all remaining entries 0 in a practical way. Suppose this is again, see, this is sparse matrix. Again, always this sparse matrix, sparse is a very important command in order for high performance computing. So I will give you as a homework to study about sparse matrix. The people who want to study the scientific computing and want to work in the numerical analysis or scientific computing, they should always use sparse matrix instead of your regular matrix. So this is the loop and the output of suppose I want a physical matrix of size 4 by 4. I will enter size and my physical parameter is 0.1. Then I am getting matrix like this. Suppose my matrix is of size 7 by 7 and my physical parameter is 0.05. I'll get output like this. See here. With the help of for loop, only we have created a very beautiful matrix. Here only diagonal entry is 40, 40, 40, upper diagonal is -20, and lower diagonal -20, and all remaining entries are 0. In this way, you can use MATLAB very brilliantly for your use. Okay. Now done. And so use MATLAB very brilliantly. And this was from my side. And thank you so much for your kind attention. And thank you for all.
Thank you, sir, for your nice presentation. Dear participant, if you have any question, please feel free to ask. You are permitted to unmute your mic and ask your query. Yes, now you can unmute your mic yourself and put your question if you have.
Hello, it's me, Dr. Vijay Chandra. My question is related to the version of the MATLAB. Which MATLAB version downloading with MATLAB version is the better option? Thank you.
Sir, please unmute your mic.
My question is,
I understood.
which one is the best MATLAB version to do the work?
One should always prefer the recent version of the MATLAB. In my case, I am having a 2018 version. I do not have to 2024 version. I am not having license copy. So I am using 2018 version also. It is also fine. So you'll not get that much affected. Only some
Right now I'm downloaded after your session. I downloaded 2024A, but it is given only 1 month trial version. After trial version, can we that means reinstall with the 2018?
No, again you have to buy a license copy only. It will not give you free actually.
Okay. So now after uninstallment, it won't give 18 version free.
No.
It is a paid. Even 18 version also paid.
Correct.
Okay, sir. Thank you.
Yes.
Hello.
Yes, sir.
Sir, can you use any online compiler instead of MATLAB?
Octave is there. If actually MATLAB is very costly, so you cannot buy that version. Means I'm not saying you cannot. Actually, it is very costly. So you can also prefer for Octave. Octave is there. It is similar to MATLAB.
It is free online.
Yeah, it is free.
For lifetime, it is free.
Lifetime. It is my Octave is a free and it works similar to the MATLAB.
So all the function is there.
No,
in
all
MATLAB?
functions will not be there. Definitely, MATLAB is the very advanced one. But in order to learn the MATLAB, if you do not have MATLAB software, you can learn it on Octave.
Okay. Thank you.
Yeah, Swapnil.
Yes, sir.
Yeah, this side, Dr. Kalla from Ekwa University. My concern is that because whether we have to use the Scilab, it is also all the command is also available, whatever the in the MATLAB, 90% of the command is available and Scilab is free of cost.
Correct.
Can you recommend that we have to use the Scilab?
No, in Scilab, what happens now? The MATLAB, the performance of the software is very good of MATLAB, and the output. Whenever you see the figures of MATLAB and
I agree with the concern, sir. But for the beginners, those who want to learn the MATLAB concept, whether they have to implement in the Scilab and Sci is open source, it is available, and all the commands we have to practice in the similar in the form of MATLAB. And later on we have to work. It's useful.
Correct. Beginner can use Scilab also.
Yeah.
Yes.
And the another thing is that, sir, in this FTP, whatever it is a very nice sessions in today. But whatever the command you are using, you can give me one sort of type of tutorial sheets where these different type of commands. So those who are participant, they can also do the practice, because it is not possible for a one day where whatever you have to create the eigenvalue and eigenvectors and all these things.
Correct.
All the participants, on behalf of ICPI participants, we can request you to share some list that will be useful.
Yes, I will share my both presentation and the codes I have displayed. I will share both the things, and people can play around it and they can learn from it.
Thank you, sir.
Yes, sir. Thank you, sir.
Dear participant, if any more question, please. I think there is no more question. The feedback form for today's session has been shared in the chat box and you can submit. Thank you, dear professor, for your nice presentation, all the content which are basic required to learn MATLAB, to choose this software for academic purpose. And you have covered from basic to advanced level, how we can define user-defined function, how we can handle the function. Then we have how we can control statement functions are also there. So all the things which you cover during today's session, and all these are very informative, very knowledgeable, and all these will be highly useful in the coming sessions. Thank you very much for today's session, and thank you to all the participants. Tomorrow we will start today's session at the same time. So please join at the right time. The another link for the quiz will also be shared with you on your WhatsApp group, but feedback form has been shared in the chat box. You can submit your feedback, and within few minutes, we will share the quiz form. So these two things are mandatory to all the participants to stay updated, and the content which are presented today will be provided to you as soon as I will get from Professor Sopanil Kale. So as soon as he will provide us, we will share all the content with you so that you can do some practice. So all that, if you have any further kind of the problem or issue, please always feel free to contact us. We will support as possible as we can do for you. Thank you very much.
Thank
Sir,
you.
I have a question. Meher Chand, sir.
Yes, sir.
Sir, can you provide me your online recording for today's session?
Yes, yes. The recording of each session will be available. The content which will be presented during all the sessions will be available, and assignment in the form of quiz and feedback. All these things will be available to all the participants.
Okay, sir. Thank you.
Thank you, sir. And now it is time to end the session, and tomorrow we will start at that same time. Thank you very much.
Thank you, sir.
Thank you, sir. Thank you.